All right. Hey, so today, we did square root yesterday. Today we're picking up with a function called the cubic function. The cubic function, like cubed, something that's being cubed. So let's start with the equation. You may be able to predict it. Y equals x, what? Cubed. Yeah, x cubed. So that's the equation. You need to memorize the name and the equation. Okay? That is just basic memory. Some of the other stuff you can derive from remembering that. So the table, for example. I'll just give you a heads up. On a quiz, I'm not going to ask you to make the table for points. Okay, the table is there for your help. If it helps you, you can draw a little table off to the side and make the table. What I'm asking you to do is stuff like, hey, draw the graph if I just give you the name. Tell me the equation and tell me the graph. Or look at this graph and tell me which one of these things it is and what's the domain and range and what's the equation for this graph. Okay, I'm not going to make you make the table, but if it helps, you should do it. So in this case, it does help us to see this. So y equals our regular graph points, -2, -1, 0, 1, and 2. Those are our regular x values, and then you plug those into the equation to get the y values. So plug them in. And start with 0. That's the easiest one. To cube something, this is no calculator. 0 times 0 times 0 is 0. What's 1 times 1 times 1? 1. What is 2 times 2 times 2? Yeah, 2 times 2 is 4. Times 2 again is 8. Okay, so 8. What is -1 times -1 times -1? Yeah, -1. So -1 times -1 is +1. And then you multiply it by -1 again, and it turns negative in the end. So it bumps back to negative. So when you cube things, that negative sticks around. It's not like when you were squaring things yesterday. And then -2 times -2 times -2 is -8. -8. So graph those points. Graph those points and see what the shape of this thing ends up being. So we have 0, 0, 1, 1, 2, 8, -1, -1, -2, -8. And so this kind of has a curved pattern to it, similar to the parabola from yesterday. But the left side curves back down instead of curving up. Okay. So that's the shape of this cubic function. And then let's think about the end behavior is what they call it. Like, what are the arrows doing on either end of the line? Let's think about that. So on this bottom side, this left side, I could plug in bigger negative numbers, right? I could plug in -6. -6 cubed is like, hundreds, right? I don't even remember. Or -5 cubed is -125. So it would just be like way down here. -10 cubed is -1,000. So it'd be like way down here. So what I'm getting at is this thing never stops going to the left. It never stops going to the left, okay? Because I can always plug in these more negative numbers to pull it further and further to the left. It never stops going left. It just gets really, really low as it does that, okay? And then the same idea for the top right. It never stops going right. I could plug in 10. And it would be at 1,000. It'd be way, way high, but it still continues going to the right. So with that in mind, go ahead and do the domain and range. Do the domain and range. It never stops going left and right. It just gets really steep. So again, we're doing, don't forget, interval notation and set notation. Interval notation and set notation. was that? Okay, so interval notation, it continues going left and right. So interval notation, negative infinity to infinity for both the domain and the range. And remember, infinity always takes parentheses because it goes up and down forever and ever, side to side forever and ever. And then in set notation, okay, anytime, this is a rule of thumb, anytime you want to write negative infinity to infinity, that's also going to go along with x such that x is real. So in the last class, it was really throwing people off when we want to use an inequality in here, like a greater than or less than type thing, and when we use x is real. If you're saying negative infinity to infinity, you're automatically saying x is real or y is real. Okay? So if you just remember that, you're in good shape. Most people, they get why we're saying negative infinity to infinity. They just can never remember what's going on in set notation. Okay, and then the set notation for the range, y such that y is real. Okay. I also had some people ask, why is it real? And that's not, that question, I think that what they're asking is like, what does that phrase mean? It's real. What do you mean real? And the answer is, this is saying that the domain is literally any number. It's any number that you could think of for x, as long as that number is a real number. That's literally what this set notation is saying. The domain is every single number you could ever think of, as long as you're thinking of a real number. And that distinction is important because in mathematics we have things called non-real numbers that we'll learn about later this semester. Okay. And then the intercept, of course, is 0, 0. Any questions on this cubic function? We feel okay about this? Okay, we good to scroll? Can I scroll down? Okay. All right. The next one is exponential. Exponential. So in exponential, the x is in the exponent. 2 to the power of x. Very good. 2 to the power of x. It's called exponential because x is an exponent. Okay, so let's go ahead and make the table from that. And I'm going to do -3 to +3 on this one, just because I want you to see a pattern that exists in there. So that's our table. See if you can fill in some of those pieces. I would start with 1, +1. Plug that one in first. That one's the easier one. And then do some of the positives. So 2 to the power of 1, right? X is in the exponent, so it's going in the exponent spot. 2 to the power of 1. What is 2 to the power of 1? 2. What is 2 to the power of 2? 4. What is 2 to the power of 3? 6? 8? 2 times 2 is 4, times 2 again, 8. 8. Don't be deceived by that. It's not 2 times 3. 2 times 2 times 2. Okay. And then, so we already see a pattern, okay? So the top of our table right now, or the bottom, the largest number is 8, but let's move backwards from the 8. What's happening every time, every step? 8 to 4 and then 4 to 2. What's happening? Yeah. We see it's dividing by 2. It's being cut in half every time. Each step backwards gets cut in half. 8 cut in half is 4. 4 cut in half is 2. 2 to the power of 0 is 1. Anything to the power of 0 is 1. Anything. Everything. Pi to the power of 0. X to the power of 0 is 1. 2 to the power of 0, 1,000 to the power of 0, pineapple to the power of 0, anything to the power of 0 is 1 automatically. Okay? And we see that in this pattern. Yes?
If I have a number, let's say 5.
So let's keep going. 2 to the power of -1. Okay, now this one's a little bit different. You learned back in Algebra 1 how to deal with negative exponents. How do you deal with negative exponents? Do you remember from Algebra 1? Yeah, I think I know what you're saying. So right now, 2 to the power of -1, if we wrote that as a fraction, it's over 1, right? And then you learned in Algebra 2 that if you ever want to get rid of a negative exponent, you take the whole thing and you move it to the bottom, okay? Moving something from the top to the bottom or vice versa, it switches the sign of its exponent. And so the 2 lands now at the bottom, and it changes that to a positive 1. And there's still a 1 as a placeholder on top. And so this becomes 1/2. Okay? And look, that follows our pattern. 1 cut in half is 1/2. Okay? So let's try that with -2. 2 to the power of -2. Okay? A negative exponent bumps it to the bottom. Okay, negative exponent bumps it to the bottom, so that becomes 1 over 2 squared, right? It bumps the whole thing to the bottom, which is what? 1 over 4, right? 2 squared is 4. And we see this, our pattern is continuing. 1/2 cut in half is 1/4. And what is 1/4 cut in half? 1/8. 1 over 2 to the power of 3 is 1/8. So a negative exponent bumps it to the bottom. And if you graph those points, look at our y values. Are they negative? No, none of them are negative. They're getting tinier and tinier as we go in the negative direction, but they're all staying positive. So your graph is never going to dip below the axis, below that x-axis, because all of those values are positive there. So let's go ahead and graph that and see what it looks like here. So 2, 1, 2, 0, 1, -1, 1/2, -2, 1/4, -3, 1/8. Okay, if I kept going, it's 1/16, 1/32, 1/64, 1 over 128, 1 over 256, 1 over 512, and 1 over 1024. Tiny, tiny, tiny fractions. Does it ever reach 0? No. It's always going to be this tiny, tiny decimal, but it will never reach 0. 2, 4, 3, 8. Okay, so our graph bottoms out, and then it jets up on the positive end. Question?
Is there ever...
Okay. So that's our graph, and let's think about the domain and range here. See if you can do it on your own. Interval and set. Go for it. I'll give you a few minutes. Okay, so hopefully the domain, you felt good about that. -infinity to infinity, right? It continues going forever and ever, left and right. Okay, it goes forever and ever, both directions. And then, of course, since you did -infinity to infinity, then you know automatically what set notation is going to be. X such that x is real. Okay, if you're saying -infinity to infinity, you're going to say the x is real thing. Okay. X such that x is real with the squiggle brackets. And then the range, how far up and down does this go? Does it bottom out? It bottoms out. We could say that it bottoms out at 0 without ever reaching 0. So we could say that the interval from start to finish, it goes from 0 to infinity, but it never actually reaches 0. So we use a parentheses with 0 instead of the square bracket like we did yesterday. Remember I said that the square bracket was for when it actually reaches that value. A parentheses is where it approaches it but never reaches it. So 0 to infinity. And then our set notation y such that y is greater than, but not equal to, just greater than 0. Because it never actually reaches 0. It's just greater than 0. Does that make sense? 1 to 5, how much sense does that make? Let me see it on your hands. 1 to 5. Okay. Does that make sense? Why that is that? Okay.
Because it's not reaching 0.
Seems like it makes enough sense. And then the intercept here, the y-intercept is 0, 1, of course, and there is no x-intercept. They are not the same in this graph, right? It's not crossing through the origin. It crosses the y-axis, but it never actually even reaches the x-axis. So there is no x-intercept in this one. Okay? Hey, the last function in this note is called the reciprocal function. And here's the equation. Y equals 1 over x. Y equals 1 over x. And here's what the graph looks like. It looks like a butterfly. Okay? That's as much as we're going to do with the reciprocal function this unit. Okay, we'll revisit this function in April. But that's as far as we're going to go right now. And that's as far as I'm going to ask you to go with it. That's pretty much it. All right? So that's it for this PDF. We've got about 5 more minutes in a different PDF. So jump back over to Cam. So to finish up today, we're going to finish up in N1C domain and range functions, that other PDF, the next PDF in the notes. Okay?